If the theory of evolution was viable, if I open this jar of peanut butter, maybe not often, but on some occasion, I should find new life inside. You may smile at this.
Oh, very good. Oh, Jesus, you're being serious. Well, then let's try to clear up what the theory of evolution is and whether it really does predict that new species will spring out of a jar of peanut butter. The one thing we all know about the theory of evolution is that it was proposed by Charles Darwin about 150 years ago. Well, not quite. The idea that organisms evolve was floating around for 2,000 years before Darwin and was revived a bit before his time by Jean-Baptiste Lamarck. But it didn't gain much ground because there was no obvious mechanism by which one type of animal could change into another. Lamarck suggested that maybe animals changed because they felt the need to change. It didn't sound very scientific, and with no evidence to support it, the idea didn't go very far. What Darwin did was to show a plausible mechanism by which these changes could happen. And let's not forget poor old Alfred Wallace, who came up with the same idea and published it jointly. The paper they wrote was this. Darwin had come up with what he called the principle of natural selection. These days we tend to call this the theory of evolution as a kind of shorthand, but that's confusing, because we also use the term theory of evolution to describe the fact that organisms evolve. I want to leave the physical evidence and the proof of evolution for the next video. In this video, I just want to look at the mechanism, to see whether, sitting in our armchairs and not doing a bit of research, we can predict evolution in animals purely on the basis of what we know, that animals replicate themselves, and that the replication isn't perfect. There's always variation. Just taking these two known facts and nothing else, what do we expect might happen if we keep copying a hypothetical animal generation after generation in a changing environment? Let's say the Hypotheticus lives in a tropical climate, grazing happily on grass and plants. We know from our two principles that not every Hypotheticus is the same. This one has been born with a slightly longer neck. This one has slightly longer legs, the third has slightly longer claws, and the fourth has a slightly hairier body. Over time, herds of Hypothetica spread across the continent. But the climate changes and the continent dries up. Only scrubby bushes and hardy tubers can survive. The Hypotheticus with the slightly longer neck can obviously get to more leaves than its neighbours. Inevitably, taller and longer-necked Hypothetica are better fed and fitter, and therefore reproduce more. A few generations later, the drought has caused overall numbers to dwindle, but there are more long-necked animals. But natural selection doesn't suddenly stop just because average neck length has increased. The longest of the long necks now has an advantage over ordinary long necks, and so the process continues. That's so easy to understand, you have to wonder why it's so misunderstood. For the sake of Peanut Butter Man, I'll break this process into steps, and we'll see where the problem lies. Surely no argument there. By which I mean children are like their parents and inherit their traits. For example, if it gets colder, animals with hairier bodies will have a slightly better chance of survival. Pretty obvious? Like genes for hairy bodies. Genes that don't confer these advantages tend not to get passed on because the animals that carry them have a lower chance of survival. After years of rejecting these simple steps of natural selection, some creationist preachers are now embracing them. Well, they have to. As more and more animal species turned up in the fossil record, Noah's Ark was in danger of sinking under the weight. So creationist preachers now propose that Noah filled the ark with different kinds of animals, and that these later evolved and branched out into the huge variety we see today. But while real evolution takes millions of years, creationist evolution squeezes all these changes into a couple of thousand. Do take a look at this great video on superevolution. But they accept natural selection with one important caveat. Now that's an interesting conclusion. What physical evidence do they have to back it up? None. Oh, all right. None. In lieu of actual evidence, creationists support their contention with one single argument, that evolution into a new species has never been observed. In mammals, that's hardly surprising. You just wouldn't notice. After all, it only took 60 years to turn this into this. But I doubt that George Bush noticed any day-to-day changes when he looked in the mirror. If every scientific phenomenon had to be directly observed, then we could wave goodbye to concepts like the flow of electricity, or the splitting of atoms, or the movement of the solar system around our galaxy. None of these can be directly seen. They're inferred from other observations. I'll leave the evidence of speciation for the next video and look at this through the example of our hypotheticus. We've seen how it can grow taller over time in order to survive a change of climate. But there may be other ways of surviving. This hypotheticus, for example, may not be able to compete well for leaves, but because of its longer claws it can dig more easily for tubers, so it would have a better chance of survival and its genes would be passed on. The question is not whether the hypotheticus would change over time, but what could possibly stop these changes from happening. Each generational change may be tiny, but millions of years of accumulated change in a changing environment leads to two completely different animals. The question is whether their DNA would by then be so different that they could no longer breed. In the next video, we'll see if there's any physical evidence to give us the answer. Anti-evolutionists have other objections which come up time and again. Well, if you're imagining something like this, then obviously you can't. But using our theory of natural selection and breaking it down into evolutionary steps, it's easy to understand. Simple organisms would have a sensory system, like the amoeba, which can sense heat, cold, and chemicals. This could then evolve into a sensory system with a central processor, just like in insects. Individuals with better organized centralized nervous systems would be able to do more things and pass on this improved trait. The central processor would get bigger and better. Again, in stages. I won't spend time explaining the evolution of the eye here because there are a number of good videos on YouTube that do that job, including this one. No, evolution requires variation. If information is a fancy way of saying bigger ears, hairier bodies, and longer necks, then fine, we know that happens. We can see it. If information means miraculously adding completely new parts, then of course that doesn't happen, and we know why. In the next video I'll show the evidence that animals adapt existing morphology for new tasks. Trying to characterize evolution as an accident doesn't change what it is, or the evidence for it, and clearly there's nothing random about natural selection itself, because genes survive only if they're best suited to survive. Mutations are just the inevitable result of DNA that didn't make a perfect copy, and they're very common. The result is variation, not some science fiction army of mutant ninja turtles. In fact, there's new evidence that mutations don't play such an important role in natural selection, and this might be a good time to look at what we've learned since Darwin. At the time Darwin and Wallace published their paper on natural selection, Louis Pasteur was developing his pathogenic theory of medicine, the idea that germs cause disease. But it would be laughable to presume that biologists haven't learned anything new about pathogens since 1860. Of course, our knowledge has advanced. So why would our knowledge of evolution be any different? Biologists now know that mutations may not be the big engine of change. DNA can be changed by proteins which turn genes on and off, a process known as cis-regulation. Epigenetics is a huge field, but it drastically changes Darwin's premise that genes are just passively sitting there, being manipulated by environmental changes around them. Putting this very simply, biologists have discovered that DNA can exaggerate traits that are being naturally selected. Instead of being the slow and steady change that Darwin envisaged, evolution seems to happen in fits and starts. It's as if natural selection is occasionally turbocharged. Cis-regulation and epigenetics might explain why this happens. These and many other discoveries don't overturn the 19th century idea of natural selection any more than modern microbiology overturns the discoveries of Louis Pasteur, but they do show that Darwin's ideas were crude and incomplete. There's a lot more to the mechanism that drives evolution yet to be uncovered. Okay, so we've deduced from the comfort of our armchairs that evolution ought to happen. At least I hope so. Now it's time to do the research and see if these ideas are supported by physical evidence. Meet me in the next video.